Hello everyone, and welcome back to what is our fourth and final part of the senior paper review. Now, just like the junior paper, before I go through the final set of 6 questions, I'll just like to make some general comments. The first thing is that, as you can see from the title, you may be running out of time by now if you're trying to go in order. This is, of course, a feature of the SMO Senior where there are a lot more small steps to do. So if you were to look at a lot of the questions in the paper, right, let's say that if we were to look at some of the multiple choice, which are supposed to be not so difficult, you would agree that they maybe each have a couple more steps on average than, let's say, a SMO Junior paper. So just based on like the amount of logic, the amount of steps you need, it takes more time, even for the questions which can be said to be easy. Now, what this means is that on one hand, because the senior cutoff is not that high, maybe that's not a concern. I have answered some of you in the chat, but I would say just straight up that for a paper like this, I think it is not going to be too different from last year. I know that I have said sometimes things that differ by 1 mark or so depending on like what the latest statistics are that I have, but I would say that a cutoff for a paper like this is going to be 11-ish, still 10 to 11. Based on last year, I don't think it will change that much. But of course, if you want to be more broad, we can just sort of say 10 to 12, and it is assuming things remain the same. Now, of course, that would mean that yes, things will be quite low. So if the scores are too low, you're not going to have, let's say, the round 2 cutoff is 10, and then like the silver is 8, and then bronze is 6, and honorable mention is 4. Of course, it doesn't have to differ by 2 points if it is pretty low. So sometimes it can differ by 1 if it is quite low. That's happened before, right? So I mean, for silver, maybe it would be more realistic to say something like about a cutoff of about 9 to 10, and then for like, let's say, bronze, maybe it would be sort of like 8 or 9, something along those lines. Like, so it's like, this is of course just ballpark, but honestly, there are no fixed guidelines for how many percent corresponds to the other awards either. So, do not take my word for it up to a ±1 degree. However, there will be many of you who have been watching these videos, you have been practicing for the SMO, and your aim could be well more than 10 to 12, in which case my advice is that you still have to know whether you are the sort of student who is able to get 20 plus questions, or does more than 10 to 12 means like 15 or 16. If you want to do a bit more, you should certainly jump around, because some of the questions take a bit more time, some of the questions may not be so obvious, and some of the questions in between, as highlighted in the previous part, are sort of like time wasters. And so you should, as we look at this last section of 6, realize that they're not easy, but they may not be objectively harder than the ones in front. One final thing to say is that for the SMO Senior, there are often going to be the so-called weird questions pushed to the back. This is not always the case, but often there have been the weird questions pushed behind. Now, the weird questions are usually the sort that are quite far away from school syllabus. They will put many of them behind. Now, that doesn't mean that they are difficult, as we will see in some of these problems. They are not really hard. Like, let's say this last one, right? But we will get there when we get there. Okay, so with all that being said, let's start off with question number 20. This is a functional equation. This is a function that you cannot guess for sure. I've also made a change. The previous value was 700 and something, which was sort of from the old edition of my paper. I did not upload the latest PDF, so sorry about that. A few days ago, it's already been changed to 1000. Your task is to find the value of f negative 64. And when you look at this here, it is pretty obvious that the numbers and the algebraic stuff are not random at all. This is x minus 1 squared, and this is x minus 1 cubed. So it is not at all random. Neither are the values, because 16, 64, and 512 are all powers of 2. And so this is also not very random either. Now, the good thing about functional equations is that you can just put values in. So if I look at it here, when it tells me that f of x minus 1 squared plus 2f of x minus 1 cubed equals to 2025, I say, I want to put it in, but then minus 16, I want it to be a square. I can't really make it a square. This is, okay, first of all, complicated by the fact that there's x minus 1 there, but x minus 1 can be anything. So you might as well just say that the property is as such that you replace x minus 1 by y. It's still true for all y. Second of all, we can realize that the negative is just there for show. Because if you replace y by negative y, you actually get this, which implies that f of y cubed equals to f of negative y cubed, and y cubed and negative y cubed is just negatives of each other, so it just means that fx equals to f of negative x for all x, i.e. the function is even. That means that the negatives can actually be ignored. To an extent, they are just there to confuse you briefly, but you can say that, all right, actually that does not matter here, that does not matter here. And once you realize that things are quite simple, because we can then put in values that we want. Right, so you just put in y equals to 4, and you get f of 16 plus 2f of 64. You put in y equals to 8, since 8 squared is 64. And then alongside the one value that, the one equation that we already have, we can certainly get f of 64 quite easily. Right? So just take 1 minus 3 to eliminate f of 16. And then eliminate f of 512. So this plus 2 times of this, and then our answer comes out to be 850. Now take note of some, well, two things actually for functional equations. The first is that please don't ask why do you know that y is 4 or y is 8. It's not why do you know. It is that for any real number, so you get to choose. It's kind of like an identity. You can always put in anything you want. So if it turns out to be useless, then so be it. Nothing to be worried about. It's just one wasted line. The second thing is that there are some instances where you can guess the function. But there are many instances where you simply cannot guess the function, either because it's very weird, or because actually there are infinitely many possible functions, just that the thing they ask you for is fixed. So you can try to guess the function, but if you look at it here, honestly, it's not obvious what the function is. Just ignore it and focus on getting the value instead. Okay, next up is 21. What is the remainder when 7 to the 99 is divided by 81? If you are doing this in the most so-called simple low-powered attempt, what you would do is to just write powers of 7 and look for a pattern, right? So 343 divided by 81, your remainder is 19, and then after that times 7, you get 133, the remainder is 52, and then after that you times 7, the remainder is 40, and clearly you realize that this may take a while. That is where this 81 is posing an issue. And so there are a couple of ways that one might go about this. The first method is that we use our Euler's theorem and stuff adjacent to it. Now, Euler's theorem is basically going to tell you that phi of 81 is 54, so 7 to the 54 is 1 mod 81. That means that if you have 7 to the 99, you can take away 54, but you can take away another 54 and actually use the inverse to help you. Now, so this is a lot of modular arithmetic tricks, right? So to the minus 9, since I've already calculated the cube, I can replace it by 19 to the negative 3. And then after that, you can calculate 19 cubed. Divide that again, which, as you can see, this is not going to be that nice. It is also not my intended method, but I'm saying that you can have this, and then after that, now you need to look for the inverse of 55. The inverse of 55, you can split it into the inverse of 5 and 11 because those are smaller. And then you're basically looking for 5 times what is going to be 1 mod 81. Okay, so 80 is negative 1 mod 81, so you can use negative 16. And then 242 is negative 1 mod 81, and so you can use negative 22. And at the end of this, you get 28. Okay, so this is pure like pile of modular arithmetic tricks, which some of you will definitely take a lot of offense to as saying that this is way too hard or this is way too strange. And then you might ask, hey, but how do you actually know this works? How do you actually calculate the inverse so fast? And the answer is that, well, there's actually a lot of calculations involved. The SMO only does this kind of thing maybe 1 out of 10 times, where they make you do a lot of random, oddly specific calculations. So we can suspect there's something better, which is the binomial theorem. Just use this because 81 is a power of 4. And powers of 6 would be divisible by 3 to the 4 very easily. Now, the good news is that when you do this, 6 to the 4 already has 3 to the 4, that's why I can ignore it. But this is still divisible by 3. So I don't need to calculate it because this is divisible by 3 and this has 3 cubed. So this disappears. And this one, 99 times 98, is divisible by 9. And there is a 9 here, so that's 81. So that also disappears. And therefore, you only actually calculate 1 plus 99 times 6. Okay, and then this one, no one's going to complain about dividing 595 by 81 and getting the remainder. So that is a whole lot nicer. And having seen the thing on the left, I'm sure some of you were frantically typing out in the chat saying, no, we can do it using the binomial theorem. Yes. Usually when I set the question and when the SMO sets the question, they are aware of, let's say, even for Olympiad methods, there may be more than one. There can be one that is possible but long, and there's one that's actually neat. And so the one on the right is neat, the one on the left is possible but long. Question 22. It's not hard. It is actually just a bit misplaced, but I'm misplacing it deliberately, that you should realize it's really not that difficult. It's pretty clear what is going on with these three. If I call this A and B, this is actually going to be B minus A. And the only way that a plus b is equal to, modulus a plus modulus b equals to b minus a is that b is positive or greater than or equals to 0 and a is less than or equals to 0. This is the only way by the triangle inequality, but also by common sense, right? You're doing subtraction, but this one you're only adding the magnitudes. So the only way that both magnitudes become plus is b is positive and a is negative, or 0. And so also don't forget that it is not or, it is and. So when we are doing the splitting into cases, always write down explicitly and or, because that is where sometimes we get messed up. Okay, but other than that, this is a simple quadratic inequality, or rather a pair of simple quadratic inequalities. I did not attempt to make the factorization of this one particularly difficult to find. Neither did I attempt to make this one particularly difficult to find. They're both just going to be two factors that are very far apart. Okay, so this is x greater than or equals to 111 or less than or equals to minus 5. This one is x is between -4 and 127. And so it is also this and this. Quite clearly, only intersection is from 111 to 127. Okay, so 17 solutions. So when you look at questions, this is why I said flip through the whole paper, because you're like, hey, that's not hard. Be careful, of course, because there are many ways in which some of you can flip a sign by mistake, but conceptually, not really difficult. Don't do the substituting back blindly, because yeah, as you can tell, substituting back into the original equation would be quite a nuisance, right? So make sure that you actually understand the logic. For some of these absolute value ones, if it's small enough, please substitute back as like a way of checking. But I don't think we want to substitute in like 111 to 127 as a way of checking. That's just way too much work. So let's not do that. Next up, 23. Pairs of positive integers such that m and n are between 1 and 1000, and m to the power 1 over n is an integer. You can just split into cases here, because the root of something is an integer is not going to happen too much. Because there are not that many powers. M has to be an nth power. So when you are doing a counting question, ask yourself whether this thing is easy to satisfy or not, meaning that is it rare? Now, rare doesn't mean the answer is small. Rare means that it is only under very specific cases. Then we count for the very specific cases, like n equals to 1 is technically going to give you 1000 cases. And m equals to 1 also will give you 1000 cases. Obviously, 1 is double counted. So this, in a sense, is a big number of pairs, but it is not like a big number of different types of cases. Right? Because apart from this, the rest are quite rare. So beyond this, I can split into cases where if m and n are more than 1, n equals to 2, you're counting squares. Okay, this is, of course, I'm just listing out what m can be. N equals to 3, you know that it's just 1 cubed to 10 cubed. But of course, when I say this, I've already excluded 1, so you can exclude 1 here if you want to, otherwise you subtract off later. N equals to 4, it's just going to be 5 to the 4. So you see that, actually this list is going to dry up very fast. Therefore, I'm not afraid of writing a long list. If 4 to the power of 5 is already 2 to the 10 is 1024. So there's just this, and then after that you've got 2 to the 6, 7, 8, 9. Easy enough to count, right? No, that's 49 or 59. So it's often the case that for these types of problems, you just need to um, go through in your mind, is it easy to cover the cases quickly? Then don't need to be afraid of listing. But of course, when you're not afraid of listing, you have to be afraid of making a careless mistake. So I have omitted that 3 to the 6 is also a case here. So this is the sort of off by one that can also happen. When you are listing, it is more likely to happen. So be extra careful of these sorts of things. Yeah, so again, some of you are about to jump into the comment section. Yes, I do make mistakes, but I do have properly written out solutions as well for reference. So I've written out the solutions elsewhere. This is just that when I'm writing it, it's a lot more of a casual way of presentation. This also applies to you, right? For some of you, you like to write everything in complete sentences. If that helps you to avoid careless mistakes, please do that. But if let's say you tend to always miss stuff when you're writing it in a way like I write it, then please write the complete sentences. Please draw a nice table or whatever you feel helps you to avoid mistakes. Right? Because there is no universal way to prevent careless mistakes. I mentioned some tips in the previous videos, but a lot of it is in your own practice. You know what things go wrong. Okay, 24. Alpha, beta are angles such that this thing here of POQ is the maximum value of tangent 5 beta. Oof. Is there anything special about 5 beta? Taken in tangent? Definitely no. So if I have trigo stuff, oftentimes you just need to sort of pause and say, is there anything nice about this? If there is, then great. The nice thing here is 3/5 and 5/13 because those are 3, 4, 5 and 5, 12, 13. So it suggests to me that I don't want to blast this open because that will be a huge waste. So instead, I'm just going to let x be 2 alpha minus beta, y equals to alpha plus 2 beta. And then to get 5 beta, I just eliminate alpha. And if I eliminate alpha, there is 5 beta. So in reality, this is not hard. But with that one thing that you need to realize, which is that I don't want to open this up because I don't actually think sine alpha and sine beta are nice. I think that these two angles are nice themselves. So write phi beta in terms of those two things instead. And so the question is tangent 2y minus x, which is not too bad. I just need to decide on my choices of tangent x and tangent 2y. Okay, so sine x is 3/5, means that yeah, if you draw your 3, 4, 5, tangent x is 3/4, but it's plus or minus. Cosine y is 5/13, means that yeah, tangent by the same reasoning. This is your y, so tangent opposite is plus minus 12/5. And then tangent 2y will also retain that plus minus. Okay, and so you end up with multiply by 25, you get plus minus 120/119. Okay, so you want to make the maximum possible value of this. That should mean that I want to make the top as big as possible and the bottom be as small as possible, which I can just by taking plus here and negative here. Right? Because this will make the top bigger and the bottom smaller. Okay, so multiply the top and bottom by like 119 times 4, and your numerical value is this. Don't panic, remember it's tangent. So tangent is allowed to be not between -1 and 1. If it's sine or cosine, then you know you've messed up. So numerical answer is 953. Last one, which is a pretty fun one if you are now doing it as a mock paper, but if this were an SMO, there will be a lot of angry people because it is quite a troll in a way. The only meta hint you have is that it's at question 25, lah, right? So can it be as easy as just taking the LCM? I mean, it can be, but that would really be a bit suspect, right? So anyway, let's understand this carefully, right? So 3 planets have a circular orbit about a star. This is how long it takes to complete one revolution. On one particular day, A, B, C, and S are all collinear. Now, of course, the orbit size is not necessarily corresponding to the length of one revolution. I just decided to draw it like this. So let's say that this is A, B, C, and the star. Now, if you were to say that I take the LCM, that's how long it takes for all of them to come back into this exact position again. But that is not necessarily the only way they can be collinear, right? For them to be collinear, do they need to be back where they were? Not for certain. They could be, but it's more like they have to be at the same place. Right? Meaning that, for example, if let me just erase all of this. If let's say that now they end up here, this is also okay. But in fact, we also have the issue that they are collinear. I never say in that order. It could be possible that let's say that they are collinear in this way as well. So that is why this is more tricky than it looks. And this is also a little bit like the sort of thing that if you're watching this after SJPO, I hope it went well for you. And yeah, it's the kind of thing that physics likes to trick you with, right? Math does that a bit less, but still can be done. Okay, so how do we actually understand this? Is that in order for them to be collinear with the star, they need to be at the sort of the same position or half a rotation away. So n days later means that they are so-called n over 300, n over 420, and n over 700 is their positions, their fraction of a revolution that they have done. You need them to either be that this, let's say 2, is an integer, meaning that they are at the same respective position, or half integer, which means that they are on opposite sides. Which is the same as saying if I take this times 2, it's an integer. Right? If it's integer or half integer, means 2 times of this must be an integer. And the same is true for the other, let's say if I take this minus this, it's also integer. So this I can compute. just subtract the fractions. Then this one, well, that clearly tells you that your minimum n is 525. And it's pretty easy to check what has happened, because with 525, this has gone 1 3/4, this has gone 1 1/4, and this has gone 3/4. So which means that if they started there, then it would be that this is the planet A, this is planet B, and this is planet C, if they had started on this line and gone this way. So this is perfectly fine. It is just pretty much a specific trap of, did you just assume it's the LCM, or do you think carefully about what collinear means? And once again, that's taking us to the end of the paper. I hope you found the questions interesting. I hope it's a useful practice. And if this is the last video that you see before the SMO Senior itself, all the best. I will see you in the live review after the competition proper. Okay, so let me know as usual in the comments below any final takes that you have, or any better solutions you have to any of these questions. I'm always certain, even when I'm the one setting the question, I may not have the best possible solution either. Okay, so thanks for watching. Bye bye for now, and all the best.